So, section 1.4. All right. So by solving three variable systems, you're going to have to be able to practice more on the two variable systems that like you're doing. So kind of built into solving three variable systems. Page 34 in your text. Number 3. Number 3 reads x plus y minus 2z is equal to 5. And we have negative x plus 2y plus z equals 2. And we have 2x plus 3y minus z equals 9. Okay, so again, let me go ahead. I'll label these for clarity. We'll call this equation 1, equation 2, and equation 3. So looking at this, I'm looking at what can I eliminate fairly quickly. Notice my z's, I use a mark through the middle, so this is a 2. I look at 1 and 2, I could quickly eliminate x's. Okay. I could do 2 and 3 and eliminate the z. There's more than one way to do these, but I'm always, suggest to do the easiest way, the quickest way. So, yeah, I think that it doesn't 1 or 2 or 2 and 3, 1 and 2 eliminate the x's, or 2 and 3 eliminate the z's. Either one of those would be fine. So let's just do 1 and 2. So let's do this. So 1 and 2 we would do. Let's do it over here. Not that color. Go with blue. We'll say x plus y minus 2z equals 5. And these are already lined up, so I can just write it as it is. Plus z equals 2. Okay. So this, bless you. So this should help you with two variable systems and the idea of eliminating one of the variables. For this particular one, the x's are already, bless you, the x terms are already in such that they will go away easily. So let's go ahead and add these two. So x plus negative x is nothing. That was the whole reason that we're doing this. Y plus 2y is 3y. And negative 2z plus z is negative z. And 5 plus 2 is 7. Okay. So to be clear, this was basically 1 plus 2. Equation 1 plus equation 2. That's what this guy is. Okay, so for those of you that are really struggling with these problems, where do you get lost with this? If you do, raise your hand, let me know. Tell me, what do you get lost in this part right here? No one? Okay, everyone's done that. Just eliminating the x's by adding. Okay? So here's the idea. I eliminated x's from these two. Now, because I dealt with equations 1 and 2, I need to do something with equation 3, with one of the others. I don't care which.
Yeah, can you use 1 and 2, the one that you did just now with 3y minus c equals 7, can you use that equation with number 3 or no?
Good question, and I would say no.
Okay.
Because I want to develop 2 equations out of using all of these. And I don't care which combinations. Because this goes back to, you bring up a good point, and it's going to make me re-emphasize something that I continue to say every time, is that make sure you include all 3 of the original equations as quickly as possible. Don't do what you may have initially thought, oh, okay, now we're going to do something with this guy. Nope, leave that guy alone. Now go back, do something with equation 3 and one of the other equations. Okay, so we know we have to deal with this guy, so let's go ahead and write him down. I have 2x plus 3y minus z equals 9. All right, because I eliminated my x's when I developed this guy, I also want to eliminate my x's with whatever I put with this guy. So I don't care equation 1 or 2. Yeah, and of course, okay, so 2. Now what do I have to do with 2 before I multiply by 2 exactly? Because that would give me negative 2x, plus 4y plus 2z equals 4. So I can eliminate the x's. So let's go ahead and do that. So multiply this guy by 2. I would have negative 2x plus 4y plus 2z is equal to 4. And let's just go ahead and do it. So if we do this, now if we add them, yep, that eliminates the x's. So I'm left with 7y negative, it's a sad looking too. 7y, now negative z plus 2z is 1z, and 9 plus 4 is 13. Okay. So let me darken what's going on here. So this is the point you want to get to. Let me label what this is. This guy here was when we did basically equation 3. We did equation 3 plus 2 times equation 2. Now, I'm being very careful when doing that. I can't emphasize enough to be careful, because these things are nasty. These are, like I said, again, some of the longest problems you do, so just be careful. You don't want to make a simple mistake. And so we're here. So that's what this guy is. I think it's pretty clear. Okay. So now we have basically where you are with what your homework is, with the 2 variable system, where you now have this and this. Okay. This looks actually pretty convenient. Let's do this. Let's find a new slide, or might shrink that. I think I might put it right here. Let's do that. So we have 3y minus z equals 7. Now this guy is 7y plus z equals 13. pretty obvious what I'm going to do here. I'm going to eliminate the z's. They're already ready to go. Adding these up, I'm going to get 10y equals 20, giving me a y value equal to 2. So I will put this and circle up with this color, or using this blur. That's our solution. That's one of our solutions, y equals 2. So that means, if I did this correctly, I should be able to plug in 2 into y into any of my equations. Bless you. Okay. Now, I'm going to obviously go back, plug this into either one of these guys that I developed, so I can solve for z. And it shouldn't matter which. There's always little points while you're doing these problems where you can check your work as you kind of go along. So if I plug in 2 into here, I should get the same z value if I plug 2 into this equation. If you don't, then you probably may have made a mistake. It's very possible you may have made a mistake. So we have, again, it doesn't matter which. I'm going to have to go to this slide, though. I don't think I want to shrink this down. I don't think it's any smaller, I don't think. You think I can make this smaller? Guys in the back, could I shrink this down? Is that as far as you can go? That's still legible? Is that even better? Worse? That's good. Okay. Okay. So y equals 2. So let's say I'll use either one of these guys. Nope, not that color. Let's go back to blue. So we have 3. I'll use, it doesn't matter which, so I'll use this guy. 3y minus z is equal to 7. If I substitute y in there, I have 3 times 2 minus z is equal to 7. So 6 minus z is equal to 7. So negative z, if I subtract 6 from both sides, is equal to 1. So z is equal to negative 1. All right, and then last but not least, it's a weird looking z. It shouldn't matter which of the 3 original equations I plug these 2 values into, I should have the same value for x. I'll just pick the first one. It's pretty straightforward. So x plus y minus 2z equals 5. So x plus 2 minus 2 times negative 1 equals 5. So x plus 2 plus 2, so x plus 4 equals 5. What's so funny? Oh my God, you guys are cracking up. I know, I'm thinking about that shit. I'm going to have to get out of the way as soon as I'm done writing this. So, subtracting 4 from both sides, x would equal 1.
We just can't understand it.
Someone said what?
You started right, and when you was talking, and I couldn't see that, so I didn't know what you were
Okay,
doing.
we'll go.
Thank you. Like following along.
Exactly.
Okay. Relax. She's serious about her math. That's good.
Oh yeah, I got her last year.
Because I was being in class like that, so
the seriousness that you take your math studies. Okay, so
So what did you do with that?
what did I do? What did I do with what?
The thing you just wrote.
Yeah, what does that equation mean? Like, that's what, that's what okay.
Yeah, but you don't be showing your work, so we don't know what you're doing.
I don't be showing my work. I think my work is pretty darn good, but I can show. I
Okay,
can.
so that's equation
Okay.
one.
This is equation 1.
Okay, it wasn't.
What's that? Like this.
You have their polite ways of saying things. Hey, Mr. Gross, I'm totally lost. I don't get this or this or this or this.
Oh, you have plugged in here right now. So you try to find the x. Okay, so you're trying to find the c. Correct.
What's the question?
Okay, so we already found y, we already found z, so we're finding x for this one.
That's the last variable that needs to be found. Yeah.
How did you get 4? Like, what did you do?
How did I get 4? Negative 1, 2, 1. What are you talking about?
I'm talking about. I think where it says x plus 4.
Okay, this 4 here. Okay.
Yeah, what did you do to get that 4?
Well, negative 2 times negative 1 is positive 2, and 2 plus 2 is 4. Divide? No. If the 4 is times with dx by addition, I'm going to subtract 4 from both sides.
What?
So this should definitely help you with your 2 variable situations. Okay, so tomorrow you're going to have a quiz on 3 variable systems. So that being said, I'll give you guys the option. Do you want me to go over 1 or 2 of the homework problems, or another 3 variable which covers 2 variables? Raise your hand if you want to see another 3 variable which covers 2 variable systems. That's what you're going to be quiz on tomorrow. Okay, that's what I would think. Okay. Any questions about this? Yes. These notes. Sure. Sure. I'll make it open book. I'll make it open book. This is crazy. All right. It's early.
Okay, what is early?
I know. I've said it. I'll say it again. I think it's too early for that. So that's not early.
Yeah.
All right. So no one has any questions on one. Completely understands this. Yes. Sure.
3.
All right, going on to the next problem. No one has any more questions about that one? Okay. Number 4. Still page 34. Number 4 reads x plus 4y minus 6z is equal to negative 1. And then we have 2x minus y plus 2z equals negative 7. And negative x plus 2y minus 4z equals 5. I'm just labeling equations 1, 2, and 3. Okay, so I first see, I don't know about you guys, hey, this looks really easy, equation 1 and 2, because the x's would go away if I had them. Yes? Okay. I always look for a twofer though. If I can get like eliminate 2 variables at one time, sometimes I have a problem like that, I'll do that. So I'm looking at it. No, that wouldn't work. So I'm going through real quick. I don't think I can. Oh, hold on. Is there a twofer in this one? There is a twofer. Did you guys see it? And I love these because boom, you get to one solve for a variable like that. Yeah. Yeah.
Or 1,
Why? Or the Z?
Look at this. If I multiply both sides of this equation by 2, which would be the exact same equation, let's be clear about that. When you multiply both sides by some constant, it doesn't affect the equation. It's the same equation, it just looks different. It's convenient because this would become negative 2y, and this would become positive 4z. I can solve for x like that. Okay. You don't always have to do that, but if you can spot it, yeah, I'm gonna do that. So let's do that. So I'm going to do 2 times this equation. I'm going to do it in blue because I'm going to leave the black as the original given. So 2 times 2x minus y plus 2z is equal to negative 7 times 2. Multiplying both sides of the equation by 2. If I distribute this, I have 4x minus 2y plus 4z is equal to negative 14. You lost the sauce? Okay. This here is 2 times equation 2.
Okay.
Okay, again, I could have just looked at 1 and 3, but this is going to be even sweeter because I'll get rid of 2 variables at once. Okay, now all I'm going to do is I'm going to write equation 3 right here. That's all I'm going to do. So equation 3 reads negative x plus 2y minus 4z is equal to 5. This is just equation 3. That's all this is here. That was this is this. Four x plus negative x. Mm-hmm. 2y, negative 2y plus 2y. 4z plus negative 4z. So 3x equals 19. Oh, thank you. Negative 14 plus 5 is negative 9. You gotta be careful because if I made that mistake, that would have been rough. And I would not have known that I made that mistake until way later on. It is right. It's too early for math. You have to. For up to me, I would only have 4 periods. 3x equals negative 9. I'm going to shrink-a-voo this a little bit. Shrink-a-voo. Yeah.
We start saying other stuff for
It's too early for some new words.
Alright, and then dividing both sides by 3 would solve for x. So x equals negative 3. And I'm going to be again continuing to circle my solutions in this nice red. Okay, so x is solved for. So when I look at the three original equations, I know that I don't have to worry about the x's. I just need to focus on either eliminating y or z. So I'm looking at these and trying to figure out what's the least amount of work, eliminating y or z. And looks like I'm going to have to multiply by some factor. I think if I multiplied equation 2 by 2, I could quickly eliminate the y's. What's that?
We didn't just multiply equation 2 last year?
Yeah, so great, I already have it, fantastic. So this I'm going to match up with, no, I can't forget this rule here. I used equations 2 and 3. The golden rule that I'll state for a 5th time here is what? I want to hear you guys say.
You gotta use one and another.
You got 3 equations as quickly as possible. Okay, so I almost made a mistake, and I wasn't going to include equation 1, and then I get the thing wrong. Okay, so let me include 1 right now. So equation 1, and now I don't care. I'm not worried about x's. I don't even look at them. I'm looking to eliminate y or z. So I'm gonna have to use equation 1.
You
So I have.
can use equation 1 and 2.
Mm-hmm.
And then you just have to simplify it.
So equation 2, yeah. So what do I want to multiply equation 2 by?
I want to say 2.
Okay. So if I multiply equation 2 by 2, I would have 4x minus 2y plus 4z equals negative 14. And I don't think I can eliminate the y or the z. So what would work?
A negative number?
3 would work because then this would make it 6z. Then I can cancel the z, eliminate the z's.
So how do you figure out the number? Just do like 3 times 2 equals 6 and then you have it?
Yeah, so the way I figured it out is because I'm looking to eliminate y or z, I don't care which. I need them to be, we'll say the exact opposite. We'll keep it addition, okay? I want them to be the exact opposite, so I want this to say become negative 4y, or this guy to become positive 6z. Doesn't matter which.
Okay.
You might choose to decide, okay, multiply by 3 gets a smaller number, that's fine. So 3 times equation 2. Okay? What would 3 times equation 2 look like? Aurora, I want you to say because I know that you are struggling a little bit with doing the mental math a little bit. What would, I know I have faith in you, what would equation 2 look like if we multiplied it by 3? The whole equation by 3.
You gotta let me write it down.
Sure.
About 3 you said?
Yes.
Would it be 6x, right?
Yep, so 6x
3y, I mean minus 3y.
minus 3y.
Plus 6z.
Very good. Negative 21, very good. So what she just did, Aurora did, she did 3 times equation 2. So this here is 3 times, I know I'm writing it small, but this is 3 times equation 2, and this here is just equation 1. 3 times equation 2. All right. If I add these, what would I get? And we can substitute this at any point. I'll do it at the end.
Wait, no, the 6x, which one is that? Equation 3, and then you times it by 6.
No, this line here is 3 times equation 2. So we're running out of time, so I'm going to bump it up. 7x plus y equals negative 21 plus negative 1, which is negative 22. So y equals negative 22. I know you want me to show all the steps, but I can't do it right now, Aurora. I'm just subtracting 7x from both sides. That's all I'm doing. And then I'm just substituting. I know what x is. I have it circled very clearly. So y equals negative 2. Is that a z? Supposed to be a z? See, that's why I stick with it. Okay, so it's definitely not a z. It is a negative 22 minus, better not be a z, minus 7 times negative 3. So this is just an addition, subtraction, multiplication. So negative 22 plus 21, negative 1. I'm going to, and you guys should know what to do from here. It doesn't matter which of the three you plug it in. Now, if you need to check, if you can't check yourself, bless you, you should be able to plug it into each one, and it better make every equation true because it's the whole system.